Welcome to Crystal Clear Chemistry channel. In this video, we are going to discuss 40 questions of chemistry of MSET level, and this is the first model paper that I am going to upload in my channel. As MSET, I am going to upload even the JEE mains and the NEET model papers. So for more updates and all, please subscribe to my channel. Let's move to the question one by one. A body of mass 10 milligrams is moving with a velocity of 100 meters per second. The wavelength of de Broglie wave associated with it would be. So here they are asking for the lambda, and we know that de Broglie wavelength lambda is nothing but h by mv. So just by substituting the h value m and the velocity, we can easily get the wavelength. But here they have given the mass in terms of milligrams. So first you need to convert this into kilograms in order to get the correct value. Anyhow, the velocity and the Planck's constant are in SI units. So convert this into kilograms so that we get the answer as 6.63 into 10 to the power of minus 31 meters. Next one. The amino acid which is not optically active is. So they're asking for the optically inactive amino acid, and if we consider the first amino acid, that is glycine, if we consider NH2CH2COOH, if we consider this carbon is not a chiral center. This is not a chiral center because there are two hydrogen atoms, and in all other amino acids, the one of the hydrogen is replaced by the other substituents, hence they are optically active. But the only optically inactive amino acid is glycine, right? Let's move to the next one. Which of the following is a second order reaction? So if we consider these reactions and all, they are the photochemical reactions where the sunlight is required, and we know the reactions which are occurring in the presence of sunlight are zero order reactions. And not only that one, suppose if we consider the reactions which involve the catalyst also comes under zero order reactions. If we consider the third one, it is a base catalyzed. This is a base catalyzed ester hydrolysis. Here they need to mention C here, CH3COO CH3. Suppose if we consider this particular reaction, base catalyzed ester hydrolysis is a second order reaction. Hence, we can easily go with the third option. But in presence of acid, the ester hydrolysis is a first order reaction. In presence of base, it is a second order reaction, right? Anyhow, let's move to the fourth one. How many chiral carbon atoms are present in a 2,3,4 trichloropentane? Pentane means 5 carbon atoms. 5 carbon atoms. And 2,3,4 trichloro. So in all the cases, 2, 3 and 4 carbons that are attached with the chlorine atoms. If we consider this particular second carbon, this is a chiral center, no doubt, because it is attached to one hydrogen and the CH3 and Cl and this whole group, right? Just like that of second one, even the fourth one also is a chiral center. Fourth one also a chiral center because it is attached to methyl group, hydrogen, Cl and this whole group. What about this third one? Third one, it appears to be chiral, but it is not a chiral carbon because it's not an asymmetric carbon because if you consider this group and this particular group, both are same. So we can say that as these two groups are same, it's not a chiral center. So total how many are there? Two are there. So the number of chiral centers are two. Next one. Graphite is a soft lubricant, extremely difficult to melt. The reason for this anomalous behavior is graphite. If we consider, we know it is having the layer structure, and those layers are held together by a weak van der Waals force of attractions. As it is soft and it is lubricant in nature, it is even difficult to melt it. So the Appropriate answer will be this fourth one because the graphite has carbon atoms arranged in large blades of rings of strongly bonded atoms with weak interplate bonds. Next one. Paracetamol is an paracetamol, if we consider it is an analgesic which relieves the pain, which decreases the pain, and it is also an antipyretic which decreases the body's temperature, right? So we can say it is both analgesic and antipyretic. The answer will be the second one. Next, placebo effect is shown by. If we look at these options, we can easily say that the methyl group is showing plus I effect because all other are showing minus I effect. It's a quite easy bit. Let's move to the next one. The reagent used in the Clemmensen reduction is Clemmensen reduction, zinc amalgam and concentrated HCl. Uh, for named reactions, it's very important to remember the reagents and as well as it's very important to expect the products and even in JEE mains 2025 phase 1 examinations also we have seen lot of questions based on reagents and named reactions. So practice more these named reactions and all. Next, when KBr is dissolved in water, K plus ions are. Whenever the inorganic salt is dissolved in water, the cation are definitely undergo hydration and we can say that it is hydrated. Whatever the K plus ions are there, the water molecules gets accumulated around the K plus ion, which is called solvation. If the water is a solvent, we can say it is hydration. And the verb for the hydration is we can say hydrated. So the K plus ions are hydrated but not hydrolyzed, right? Next, maximum number of molecules of CH3I that can react with a molecule of CH3NH2R. CH3NH2 is a primary amine and here we have two hydrogen atoms. No doubt the two hydrogen atoms are replaced by these two methyl groups. But if we consider the amine group, the amines readily convert into ammonium salts also, where we get R3N type, R3N plus type salts. So here we can say that 3 moles can react. Hence the answer is 3. Next one. When a sulfur is evaporated, sulfur sol is evaporated, sulfur is obtained. Sulfur sol is nothing but a colloidal solution. And on mixing with the water, sulfur again solution is not formed. What does it mean? On mixing with the water, it is not forming the solution means definitely it must be a hydrophobic sol. Phobic means hating, hydro means water, water hating sol. Sol nothing but colloidal solution. Next, methoxymethane and ethanol are. Methoxymethane CH3OCH3 and then ethyl alcohol C2H5OH. If we observe these two compounds, they are having the same molecular formula but they are differing in the functional group and hence we can say that they are the functional isomers. Right? Next one. For the reaction Fe2O3 plus 3CO gives 2Fe plus 3CO2. The volume of carbon monoxide required to reduce 1 mole of ferric oxide. For this type of problems, we need to look at the balanced chemical equation. We can say it's a stoichiometric calculation. Here 1 mole of Fe2O3 is reacting with 3 moles of carbon monoxide. That means 3 moles of carbon monoxide if we consider it occupies 3 into 22.4 liters under STP conditions, right? So if we multiply, we get an answer as 67.2 liters. Here the dm cube is nothing but 1 liter. 1 dm cube nothing but 1 liter. Next, a gas deviates from the ideal behavior at high pressure because its molecules. Under high pressure, always the gas molecules attract one another According to the ideal behavior, there is no force of attractions, but under high pressure, definitely the forces of attractions are not negligible. We can say that they deviate because they attract one another more. Let's move to the 15th question now. The reagent used to convert an alkyne to alkene. So here, triple bond is converting to double bond. We can easily say that the hydrogenation must take place here. It can be done in presence of catalyst like palladium. So the direct answer is the palladium hydrogen in presence of palladium as a catalyst. Catalytic dehydrogenation of a primary alcohol gives um, catalytic dehydrogenation, that too for primary alcohol. For example, if we consider CH3, CH2, OH, it's a primary alcohol. This hydrogen and this hydrogen will be eliminated. That is what dehydrogenation. You will get CH3, CHO, right? Which is an aldehyde. So suppose if we consider the primary alcohol, it readily gives CHO, whereas the secondary alcohol readily gives ketone, right? Anyhow, here they have given the primary alcohol, so aldehyde is the correct answer. Next one. A complex compound in which oxidation number of a metal is 0. If you look at the complexes, the CO is a neutral complex where the oxidation state is 0. And metal carbonyls, if we consider, the oxidation state of metal is always 0 as the ligand is neutral. Hence, the third one is the correct one. Next one. N-propyl bromide on treating with alcoholic KOH produces alcoholic KOH. It is a dehydrohalogenating agent, right? Dehydrohalogenating agent. If we consider that N-propyl bromide, which is nothing but CH3CH2, CH2Br, if we consider during the dehydrohalogenation, we get an unsaturated compound where there is a double bond between C and C. And propene we get, right? So where is the answer? Here is the answer. The second one is the correct one. Let's move to the 19th one. A ligand can also be regarded as ligand. In a coordination compound, ligand role is to donate the lone pair, to donate the electron pair, we can say. The one which readily donates the lone pair of electron is nothing but a Lewis base. Hence, we can say ligand is a Lewis base. Whereas central metal ion is Lewis acid, as it is accepting the electron pair, right? Now, let's move to the 20. The color of the sky is due to. We know the sky is blue in color because of Tyndall effect. Have no already. But directly they did not give the Tyndall effect reason. Instead, they have given the definition of Tyndall effect, which is nothing but the scattering of light. Here, especially the blue color is because of the wavelength of the scattered light. And we can say that second one is the correct answer. Let's move to the next one. Yeah. Helium is used in balloons in place of hydrogen because it is. We know helium is incombustible gas, hence we use that in balloons. Easy one. Next, the basic principle of Cottrell's precipitator is, in that precipitator, the precipitation takes place because of the neutralization of the charge which is present on the colloidal particles. So, the neutralization is the basic principle. Next one, N2 plus 3H2 gives rise to 2NH3 plus heat. What is the effect of increase of temperature on the equilibrium of the reaction? Here, this is the Haber's process, and they're asking for the effect of increase of temperature. So immediately we need to recollect the Le Chatelier's principle. As it is a exothermic reaction, low temperature favors the forward reaction. But as they increase the temperature, definitely the backward reaction takes place, backward reaction takes place. So we can say the equilibrium will be shifted towards the left. Next, amines behave as amines. Amines are nothing but, for example, the general formula of primary amine is RNH2, where the nitrogen carries the lone pair, which it can donate, hence it can act as a Lewis base, as we discussed earlier. Next, the dalda is prepared from oils by, see, dalda, vanaspati and all, they prepare in the industries from the oils, especially by catalytic hydrogenation in presence of nickel. In hydrogen its compounds lesson, we have this concept, and hydrogenation nothing but reduction. So oils on reduction readily gives, we can say liquid oils readily gives solid fats on reduction. So the second one is the one, correct one. Next, 26. The number of disulfide linkages present in the insulin. It's a theory bit. Insulin contains two disulfide linkages, hence the answer is 2. Next, the IUPAC name of the complex ion they have mentioned. Even in IPE also you need to write the IUPAC names for 2 marks questions, right? So it's very important. See, especially in IPE, whatever the 2 marks that you are reading in any subject, that they are very, very helpful for solving the MCQs also. So that's the reason, don't neglect the IPE exams. Anyhow, come back to this complex. To name it, first we need to look at the ligands. This is amine. How many are there? 5 are there. Pentaamine and ONO. This is nitrito. So pentaamine nitrito, and this is cobalt. Cobalt carries +3 charge. So pentaamine nitrito, cobalt 3 ion, because ONO carries -1. So the total charge on the metal will be 3. Hence we need to show that in the Roman number, and the third one is the correct answer, right? Next, arrange the following in the increasing order of their bond orders: O2, O2 plus, O2 minus, and O2 2 minus. Here, um, especially in case of O2, it's very easy to calculate the bond order. There is a shortcut. Let me discuss that. So O2 means O double bond O. We know already the bond order is 2. Bond order is 2. And if we consider O2 plus, here as there is a plus, you can say that it is its bond order is 2 plus 0.5. For example, O2 2 minus, if we consider, again O2 means 2. As there is a minus, you subtract 0 point from it. 5 from 2, then you will get a 1.5. For example, if they ask for O2 2 minus, so O2 2 minus nothing but again 2 minus 2 into 0.5, right? Nothing but 2 minus 1, nothing but 1. So the correct bond order is 1 for O2 2 minus. Anyhow, they have asked for the increasing order. So 1 is less than 1.5, less than 2 we can say, and then 2.5. That means this is the correct answer, right? Now, let's move to the 29th question. The pH of 10 4 minus 8 molar HCl solution is. Whenever we have seen this, whenever we see that, whenever we see this 10 4 minus 8 molar HCl solution, immediately we need to recollect that if we consider the water itself has a 10 4 minus 7 H plus ion concentration. But if we consider 10 4 minus 8, it is less than 10 4 minus 7. That means for this particular molar solution, we should not neglect the H plus ion concentration from the water. So add these two, 10 4 minus 7 plus 10 4 minus 8, you will get some number, right? That H plus ion concentration. And if we apply the negative logarithm for that H plus ion concentration, then only we get the answer as 6.96. So the value is in between 6 and 7. And pH we can't directly calculate just by looking at the value. Don't say that the pH is 8 for this, because as I said earlier, the H plus ion concentration, that is 10 power minus 7 from the water also must be considered, as the solution itself is less concentrated than the water. Okay. Anyhow, let's move to the next one. For reaction to be spontaneous at all temperatures. Um, no doubt the reaction is spontaneous only when delta G is less than 0 and delta G is negative. At all temperatures, it must be spontaneous, means definitely delta H also must be negative. Hence, the answer is the fourth one. Which of the following can participate in linkage isomerism? In order to participate in the linkage isomerism, the ligand must be ambidentate ligand, where more than one atom must be present in the ligand as the donor atoms. So if we consider this NO2 minus, it also has oxygen ONO minus, where it can donate. So this type of ambidentate ligands can exhibit the linkage isomerism. Hence the fourth one is the correct one. Which of the following has the highest bond order? So first we look at the options. Options are very general options they have given, and without calculating the bond order itself, as we know already, hydrogen exists as H dash H, O2 exists as O double bond O, and N2 exists as the N triple bond N. The bond order is 1, 2 for O2 and 3 for N2. And for this helium, we know already it is a noble gas, and noble gases are monoatomic. That means it can, sorry, that means He2 molecule does not exist, so bond order is 0. But they are asking for the highest bond order, right? So the answer will be N2. Next one. Which one of the following represents the Lewis structure of N2 molecule? I think they have to give the dots here. N triple bond N must be there. So there is some mistake in the options. Anyhow, N triple bond N we know, and both 3 and 4 are there, but according to the dotted structures, here there must be a lone pair onto the nitrogen, and fourth will be the correct one. In the following elements in the following element with the highest ionization energy, there are different factors of IE, right? One such factor is the stability. The stability that to with respect to the electronic configuration. If we consider the third one, it is half-filled configuration, which is highly stable in nature with the high ionization energy value. So we can say the third one will be the highest because of the half-filled configuration of nitrogen. It's not nitrogen, it is phosphorus, right? Anyhow, next one, in the conversion if Br2 is converted to BrO3 minus, the oxidation number changes to. So Br2, it is an element in the molecular form. The oxidation state is 0. In BrO3 minus, that means x plus 3 into minus 2 is equal to minus 1. So this implies x will be the 5. So we can say that 0 to 5 is the change in the oxidation state. Where it is, yeah, here it comes, the fourth one. 36. An example of autocatalysis is, we know already KMNO4 acts as a self-indicator. In fact, it is an autocatalyst in the titration. Hence, the first one is the correct answer. Next, during the fusion of an organic compound with sodium metal, nitrogen of the compound is converted into. This is a Lessine test where the organic compound is heated with the sodium metal in order to convert the element into ionic compound. For example, if you consider the nitrogen, it converts into NaCl. If we consider the sulfur, it readily converts into Na2S. And if we consider the halogens, halogens are readily convert into sodium halides during the lesson test. They have asked the nitrogen here, so we can say that it converts into NaCl, which is an ionic compound, sodium cyanide. Next one, the reaction sodium ethoxide and ethyl iodide, ether is obtained here. So we can easily recognize that it is a Williamson synthesis, which is again a named reaction and which is very important reaction in order to prepare the ethers. So sodium or potassium alkoxides with the alkyl halides readily gives ethers, right? Now let's move to the last two questions. In fact, they have given which one of the following would not evolve when treated with the sodium bicarbonate? Would not evolve carbon dioxide when treated with the sodium bicarbonate. In order to evolve carbon dioxide with sodium bicarbonate, definitely the organic compound must contain COH group. If we consider salicylic acid, benzoic acid, nitrobenzoic acid and all contain COH group, whereas the phenol contains only the OH group, so it cannot liberate the CO2 gas. Hence, the third one is the correct one. Let's move to the question number 40. In the following sequence, they have given a total of 4 steps. The compound D they are asking. Let me check the first one now. In presence of red phosphorus and iodine means the alcohol, the hydroxy groups readily substituted by the iodide ion. So you will get ethyl iodide here. With Mg means definitely we get CH3CH2 MgI, which is a Grignard's reagent, right? So Grignard's reagent we got as B. Grignard's reagent plus formaldehyde. So Grignard's reagent plus formaldehyde immediately gives primary alcohol, right? Primary alcohol. Uh, because with other than formaldehyde, aldehydes readily gives secondary alcohols and ketones readily gives tertiary alcohols with Grignard's reagent. Anyhow, as it is a formaldehyde, we can say C is a primary alcohol and that too the alcohol with three carbons on hydrolysis, right? So primary alcohol with 3 carbons means the first one is the correct one, N-propyl alcohol. Because if you consider this propanol, this is not the alcohol, aldehyde, right? If you consider N-butyl alcohol, it contains 4 carbons, but the product must contain 3. So the correct one will be the N-propyl alcohol. Yes, that's all for today. So if you like the video, please subscribe to my channel for more updates.